Hi everybody, so we're going to be doing math today. Okay, so the problem we're going to be solving today reads, a population of bacteria in a culture increases according to the model P equals 300 times 2.7 to the 0.02 power times T, where T represents the number of hours and T equals 0 corresponds to 9 a.m. since that is our starting hour. Now part A says, use this model to estimate the number of bacteria at 11 a.m. So here's the first thing we're going to do. Here's our problem. We wrote the problem representing P to get the total number of bacteria at 11 a.m. It will be 300 times 2.7 to the 0.02 power times T. So first thing we're going to do for our equation 300 times 2.7 to the 0.02 power times T is we need to substitute T for 2 because it is 2 hours in between our starting time 9 a.m. and our present time 11 a.m. So you gotta write that first. So now that we have substituted T for T, now we have to do the 0.02 times 2 to get our exponent value. So it will be 300, 3.7, and then 0.02 times 2 is 0.04. So it will be 2 to the 0.04. Okay, and now that we got our equation, you have to type it into your calculator. So it will be 300 times 2.7 to the 0.04 power, which will give you our final answer of 312.2. Round it to the nearest tenth. And then we have to go to part B. Okay, then we move on to part B, which is graph the function at the name the p-intercept. Describe what the p-intercept represents and describe a reasonable domain and range for this situation. Okay, so to graph the function, we need to make our domain and our range values. And one thing I have to point out is our domain range is going to be this t up here. So x is actually t. And then y is going to be our p-value because that is going to be our answer to the problem. So y equals p. There you go. So our first domain value we are going to use will be 0. And since we substitute t, it will be 300 times 2.7 to the 0.02 times 0. Okay. And for that, since 0 times 0.02 is going to be 0, then we do 0 times, and then we do 2.7 to the 0 power, which is 1. And then if you do 300 times 1, that will give us our first range value of 300. So then our next domain value is we're going to do 1, so we have to substitute that in for 300 times 2.7 to the 0.02 power times 1. So then we're going to do 1 times 0.02, which is going to be 0.02. So then we just solve the regular problem of 300 times 2.7 to the 0.02 power, which will give us approximately 306. And then our last domain value is going to be 2, which is what our original problem was for the 2 hours. So it's going to be 300 times 2.7 times 0.02 times 2. So then what you do is you do the regular problem of 0.02 times 2, which is 0.04. Then it's 0.04 times 2.7 times 300, which will give us 312. Okay, so now that we have found our domain and range values, now we have to plot them on the graph. So our first domain value was 0, so we have to start on the origin and go up to 300. which is the place of the dot right there. And then our second domain value we chose was 1. And 1 gave us the the range value of 306. So that would just go up here. And then for 2, our answer was 312 for the range value. So we just go up here. So if we just do a line, it will just keep going up. Remember, the p-intercept is 300. So at 9 a.m., the amount of bacteria is 300.